Good morning, everybody. Today is day 21 of Math 133, and we are going to cover the Chapter 9 review. It is on page 495 in your course pack. 495. Right? And there are 5 pages, so make sure you grab all 5 pages. A lot of our worksheets have been 4 pages. This one's 5. Chapter 9 review. Yeah. Okay. Chapter 9 is all about confidence intervals. So in chapter 8, we talked about the central limit theorem. The central limit theorem says that when you take a sample uh, and you look at like the mean of that sample, your mean for that sample is going to be pretty close to your population mean. How close? Well, that's what the confidence interval is going to tell you. It's going to tell you that when you take your random sample, that you should expect that the mean of your sample is going to fall somewhere in this range. Okay. And because of that, that should tell you that the population will fall somewhere in that range. Okay. So um, the population mean, you're never going to know exactly what the true value is, right? We can never be at 100% confidence because in order to be at 100% confidence, you have to sample the entire population. You have to measure the entire population. And the whole point of a sample is you can't do that, right? The whole point of, when you have a giant population, that's why we take a sample. If you can already measure the whole population, then just measure the whole population, right? So, um, but usually we can't. And so the confidence interval is going to give you like, okay, well, I don't know what the true value is, but it's somewhere around here. Okay. So, and we can do all this confidence interval stuff because of the central limit theorem. Okay, so thank you, central limit theorem. All right. Just like all of our worksheets, we're going to go through, we'll give you some hints, and then we'll go back through and fill in anything we skipped. So, uh, a 2020 CDC report, it was found that 52.6% of Michigan residents over 60 have been vaccinated for shingles, 1.9% margin of error, 71% confidence. What is the population? So population is all something, okay? So while Donna's got it, in this case, it's all Michigan residents over 60, okay? Um, and then for your confidence interval, it'll be a lower bound, comma, and upper bound. Okay, so it's two numbers here. Okay. Um, Alpha is the opposite of your confidence level. So if you take your confidence level plus your alpha, you get 100%. Okay. Um, all right. So I think that's all the hints on that one. Uh, Question 2. Researcher wants to construct a 93% confidence interval for the population, sorry, for the proportion of American women that say willpower alone is not enough for most people to lose weight. Estimate how many American women need to be surveyed if no prior estimate of P is available and the researcher wants to be within 2.1% of the true error. So we need to give the formula. We need to do the substitution. And there's the formula for this is trying to figure out how big of a sample size we need, and that's going to be on page 261, single population sample size formula. So, uh, how many, so page 261. Okay. There's two formulas. There's this one where if you have a prior estimate, you can use the P and the Q from last time you did this research. If you've never done it before, you have no prior estimate, it's 0.25 out in front. And then Same stuff in there. Okay. Um, Pew Research poll in 2024 estimates this proportion to be 0.71. Using this estimate, how many? Okay, so now they gave us a prior estimate. So now we can use this one instead. Okay. And there's a, okay. By the way, whenever you're doing sample sizes, you'll always need to make sure that you round up to the nearest whole number. Okay. So when we're talking about percentiles, we will round down. Talking about sample sizes, we will round up. Everything else in the class, normal rounding rules apply. Okay. But for those two exceptions, we do special rounding. Okay. Um, by the way, so these two formulas, so like where does this 0.25 come from, right? Um, so if you have no prior estimate, so what percent of American women say willpower alone is not enough for most people to lose weight? Um, I have no idea. Like if I don't have a estimate, then how do you even go about, trying to calculate your sample size? Well, let's just say it was 50%. Okay. I don't know, just pick a number in the middle, 50%, right? So if you do P hat is 50%, that would mean Q hat is 50%. So what is 50% times 50%? 0.50 times 0.50 is 0.25. That's where the 0.25 comes from. It's basically if you have no prior estimate, if you have no clue what P is going to be, just use 50%. Just use a number in the middle and then go from there. Okay. Um, and that will actually give you the largest sample size that you could get using this formula. So actually, these are the same formula where p hat is 50%. And if your prior estimate is 50%, then you're not going to get any advantage using this formula. It's the same. Okay. So you really get an advantage using this formula when your number is anything farther away from 50%. The farther away it is, the smaller the sample size that you actually need. All right. That all said, let's go on to the next page. Find the following. So, the formula for P hat probability is the number of wanted outcomes divided by the total. Okay. So wanted is X. Okay. X is the number of successes. Okay. N is your sample size. So you're going to need to use this formula for number 3. Okay. All right. Number 4, a CDC study in 2024 found that a random sample of 2,000 adults who were 60 years old, vaccinated for tetanus. Okay. So, P hat, Q hat, verify the conditions for constructing a confidence interval for P. So, to verify the conditions, it's the same conditions for central limit theorem. And we're going to be checking these like all day today. Okay. You need to check that your sample is random, it's independent, and normal. Okay. Um, if all of those are yeses, that means that you can construct a confidence interval. So construct a 96% confidence interval for P, give the formula, substitution, and result. Okay. This is on page 259. So formula you need is this one right here. And then substitute, you plug in all the numbers you've got. And then your result. You can either do stat proportion stats, one sample with summary, or you can use the normal calculator to get your Z, and then Desmos calculator to type it in, get what your result is. Okay. Interpret, we all know, we see the word interpret. That means that we are writing a sentence, right? A sentence in English. Okay. I don't believe we have a script for that, which is totally we can use logic on that. Okay. Page 497. A zoologist wants to estimate the average weight of the male giraffes in captivity. To do so, she will construct a 90% confidence interval. Margin of error, she knows the San Diego Zoo study that male giraffes overall have a standard deviation of this. How many giraffes does she need to study? Give the formula. Do the substitution. And the result, right? So where is this formula? So are we calculating a confidence interval or are we calculating a sample size here? So she wants to make a confidence interval, but she's asking how many. Yep, so Caleb's got it. We're looking for a sample size here. So this is page 261. And on page 261, so there's three formulas for this. There is, if you have a prior estimate for your P, if you have no prior estimate, that's for proportions. There's also this one down here, which is sample size for population means. So which one are we using here? So we're looking at giraffes. Are we measuring proportion or mean? Question number 5. Zoologist wants to estimate the average weight of the male giraffes in captivity. Rachel says we are measuring mean. That's correct. So we're going to do this formula. Now, for proportion, there are two formulas. One, if you have a prior estimate, if you've done this study before, and one, if you have no prior estimate. No prior estimate, like just use 50% as your guess, and that's where this 0.25 comes from. For a mean, there's only this one. And you have to have a prior estimate. You have to have a prior standard deviation. Okay. Why don't we have one where there's no prior estimate? Well, it's because you can't just pick a number in the middle. Like you can't just pick 50%. Okay. So if I asked you, what is the standard deviation for the weight of giraffes? I, I have no idea. I don't even know how much a giraffe weighs. I have no clue, right? So you can't even say like, I don't know, use a number in the middle, like, I don't know, 100 pounds? I have no idea. So, because of that, there's no formula for prior estimate because there's no way to really make a fair estimate. Okay. So anyway, that's fine. So we're going to be using the one for means. Okay. Luckily, the San Diego Zoo has a standard deviation for their giraffes at 541. Standard deviation is 541. So my guess of 100 was way off. Okay, it wasn't even close. So, okay. Next, so this stuff down here, we're talking about like sample size. Should it be bigger or smaller, depending on your confidence level and your margin of error? All of this is talked about on page 207 and 208 in your course pack. Okay. But I like to just remember that if you want to be more accurate, you need a larger sample size. That's just the way I like to remember it. But if you want to refer to the, you want to refer to page 20728, that'll help you with these ones. Okay. According to a recent FDA study of 64 million people, was found the average American consumes this much sugar, margin of error, compute the confidence interval. Um, okay, so I remember that your alpha plus your confidence level is 100%. Okay. Um, compute the critical E values. So on page 259, so page 259 in your course pack is your exam notes packet, right? And there's a formula for confidence intervals for proportions and confidence intervals for means, okay? And they're similar, right? You take your x, your p hat or your x bar, plus or minus, and then z alpha over 2, t alpha over 2, standard deviation over square root of n, okay? They're similar. But one of the big differences between the two is this one is using z, which is the normal curve, and this one is using t, which is coming from the T curve, which is the student T curve, um, which looks very similar to the normal curve. It's not exactly the same, okay? But it looks similar. There's one big difference between the Z curve and the T curve, and that's that the T curve requires this degrees of freedom, okay? So uh, degrees of freedom is your sample size minus one. Okay. So in this case, they said the sample size was 64, which means one less than that. Now, pay attention to whether you have the degrees of freedom and you're trying to figure out the sample size, or if you have the sample size, you're trying to figure out the degrees of freedom. They're always off by one, but one is bigger than the other. Okay. Sample size is always going to be one larger than the degrees of freedom. Okay. Anyway, so that's all on page 259. Um, don't forget to do shading on this. And let's go to the next page. Page 498, number 7. During the academic 2021 year, a researcher gathered the in-state tuition for a random sample of 15 public four-year colleges in the U.S. If the average in-state tuition was $24,000, standard deviation 9,000. Verify the conditions are met in order to construct a confidence interval for the population mean, which is mu. So we need to make sure that our sample was random, independent, and okay. So for normal, when we're checking those conditions, right? Uh, you can, so for means, your n has to be bigger than 30, right? But if you have what's called a normal quantile graph, you can look at it that way instead, okay? Uh, yeah, we've talked about that before. So, construct your 90% confidence interval for mu, give the formula, substitution, result. That's on page 259. Okay. All right. And then interpret means write a sentence. Yeah. So right here for normal, for population mean, n has to be bigger than 30, or you need a graph that's shows it's normal with no outliers. Okay. Last page is page 499. Researcher for the Bureau of Labor Statistics created a confidence interval for the amount that U.S. households spend on transportation. So they give you all of these results here. Okay. So your confidence level and your alpha are related. I've already said it before, but I'll add it here as well. Confidence level plus your alpha is 100%. Your degrees of freedom is n minus 1. Okay. Point estimate, that is the sample proportion or the sample mean. Okay. And then the margin of error you're going to need to calculate. So when you construct a confidence interval, so this is my x-axis, let's say, and I'm trying to figure out what's the average or the proportion of something. Okay, average height of people in the U.S. or what proportion of M&Ms are red, or I don't know, how effective is my vaccine going to be? You know, what percent of people are going to buy my product after they see my commercial? Whatever. So you can't measure everyone. So you have no idea where your mu is going to land or where your p is going to land, somewhere along this line, right? So you take a sample and you calculate that right here, this is the sample result. This is the point estimate. It's for means, it's your x bar. For proportions, it's your p hat. Okay. So this is close to the population value, but you might be off by a little bit. How much are you off by? You are off by what's called your margin of error. Your margin of error, you add and subtract your margin of error, and that will give you your upper limit and your lower limit. Okay. So from your upper limit to your lower limit, there's two margin of errors. So if my margin error is like, say, 10 inches, then this would be up by 10 inches, I get to the middle, and then up by another 10 inches, I get to here. So this is a total of 20 inches. Does that make sense? So that means that to calculate your margin of error, you can either take your upper limit minus your x bar, and that'll give you this distance, or you can do x bar minus this, that'll give you that distance, okay? But if you don't have x bar and you just have the upper limit and the lower limit, then what you need to do is you can take the distance from upper limit to lower limit, which is upper limit minus lower limit. That'll give you the distance from the top down to the bottom, but that's not a margin of error, that's 2. So you would then need to divide that by 2. Okay, so this formula is not necessarily anywhere on your exam notes packet, so maybe it's something you want to have set aside on your 8.5 by 11 piece of paper. But to calculate your confidence interval, you take your point estimate, which is your p hat or your x bar, then you add and subtract your margin of error, and that gives you your upper and lower. Okay, so if you want to calculate what your margin of error is based on your upper and lower, then you need this. Okay. All right. All of this narrower, wider stuff, find that on page 207 and 208. Okay. And I think that is all for hints today. All right.